So we want to construct an equation for this rational function. What do we recognize? Well, there is an asymptote here at x equals -2, and there is an asymptote here at x equals 1. But they're different sorts of asymptotes. You see, at -2, on one side it's going up, on the other side it's going down. When that happens, that's multiplicity 1. But you'll notice here at 1, it's going down on both sides. Going to -infinity as I approach from the right, going to -infinity as I approach from the left. If that's the case, then what do I have? Then I have a situation where x equals 1, but that's a multiplicity 2 asymptote. And remember, the asymptotes are going to be defined when the bottom is 0. So the bottom is 0 when x equals -2. The bottom is 0 when x equals 1. So let's take a look at that. We said x equals -2 and x equals 1 were vertical asymptotes. There's more paper here. So again, we have our two vertical asymptotes. One of them was at x equals -2. But again, in that situation, it was going down on one side, going up on the other. So that's going to be multiplicity 1. And then we also had x equals 1, but that was heading this direction. That'll be multiplicity 2. So if x equals -2, that means x plus 2 is 0. If x equals 1, that means x minus 1 is 0. Those are both going to be downstairs. With the multiplicity, x plus 2 to the first power is downstairs, and x minus 1 to the second power is downstairs. Now let's go back and take a look at our picture and see what else we know. I have an x-intercept at -1, and I have an x-intercept at 2. So -1, 0 is on the curve. 2, 0 is on the curve. So how does that help me? -1, 0, 2, 0 are in essence are zeros of the function. So x equals -1 is a 0. X equals 2 is a 0. So x plus 1 is 0. X minus 2 is 0. Those are going to be on the top of this thing. So right now I have r of x. On the bottom, previously we said x plus 2 to the first and x minus 1 to the second. Now we're saying on top, to get an x-intercept of -1, I need an x plus 1 upstairs. To get an x-intercept of 2, I need an x minus 2 upstairs. But this may not be the whole story. There may be a multiplier other than 1 in front of all this. So we're going to look to see if we can find out what A is for this equation. So let's go back and take a look at it again to see what other information do I have that I could use. It's this point right here, 0, -3 is on the graph. That means r of 0 equals -3 when x equals 0, y is -3. So plugging all that in, what is that going to give me? -3. So again, here's what we have. 0, -3 is our point. R of 0 is -3. When x equals 0, y is -3. So -3 is r of 0, which is a times 0 plus 1 times 0 minus 2 over 0 plus 2 to the first power and 0 minus 1 to the second power, which is a times 1 times negative 2 over 2 times negative 1 squared, which is a times negative 2 over positive 2, which is negative a. So what I have right now is I have negative 3 equals negative a. Dividing both sides by negative 1 gives me a equals 3. So plugging that in now, I have a finished version of r of x. A is 3, so we have 3 times x plus 1 times x minus 2 over x plus 2 times x minus 1 squared. So let's take a look at Desmos and see how well this coordinates. First, we'll take a look at our thing. So again, from negative 9 to 6, from negative 8 to 3. So we'll do our best to make sense of that. And then I want to go back and look at Desmos. And what do I believe my function should be? A, 3 times x plus 1, x minus 2, divided by x plus 2, x minus 1 squared. And how similar does that look to what we had on the other page? What were our points of interest? 2, 0 here, negative 1, 0 there, 0, negative 3 there, asymptote at 1 heading down on both sides, asymptote at negative 2, negative 1, 0 is a point, 2, 0 is a point, and 0, negative 3 is a point. So we can see those 3 points. We can see the asymptote at x equals negative 2 and x equals 1. How similar does that look to what we had on the screen that we started with? If we look at that, what do we have? I'd say that looks pretty similar. I'm feeling pretty good about where we are.